Many of you we've talked about it, we've had this session at Atmospheres and so on, but I'm really pleased to have a chance to get to a wider audience for folks that are at home or at work that may not have been following this. So Aruba is really active, and we're partnered with other companies in the industry to try to get additional spectrum opened up for Wi-Fi. The 5 gigahertz band, as you know, is starting to show a lot of strain, and of course, we were disappointed that the middle of the band, the Uni 2B band from 5350 to 5470, as it turns out, there are incumbents in that band that just are not going to be possible to share with. And so we've been working for a couple of years to look at the next big block of spectrum where we can start to deliver a lot of 80 megahertz and 160 megahertz channels, so we can really get to gigabit types of speeds regularly. We're pleased that Chairman Pai has taken kind of a leadership role on this topic. There are rulemakings in both the US and in Europe. Today we're going to talk primarily about the United States, just given our limited time. But to give you some sense of what's on the table and how game-changing this is, so there's a rulemaking underway right now in the US that's looking at potentially up to 1,200 megahertz of spectrum. That's enough for 59 20 megahertz channels, 14 80 megahertz channels, or 7 160s. And so this is just phenomenally powerful, we think, because most of our customers, and I've talked to you offline at past events, right, that we think the dominant deployment modes in the enterprise today are 40 and 20 megahertz channels, which is very frustrating to me because we ship products that are capable of 80 and now 160 out of the box. And for customers to sort of defeature those products, right, the minute they install them is really, it's disheartening at some level, but on the other hand, that's what we have to do to maximize the capacity. So we want to get to a world where we can run, all 80s all the time. Europe is looking at 500 megahertz in the lower part of the band, so not as much, but we're optimistic that it's the same incumbents in the upper part of the band, and they want to take a more conservative approach, which is very typical for Europe, so they kind of want us to show that we can make it work down there, and then they'd look at the upper part of the band. So here in the US, so the rulemaking process, for those of you that aren't spectrum policy people, is convoluted and challenging. Basically, you can start proceeding around a new band a couple different ways. You can file a petition, or if you're fortunate, the FCC, if it's a significant matter of public interest, will initiate on its own what's called a notice of inquiry, which is what happened with us after some lobbying to that effect. And then you go into what's called a notice of proposed rulemaking, where they put out a big document, we ask a lot of questions and so on. There's a period of 90 days where all the different sides can file on the record. And that all happened last year and earlier this year. And then we're sort of in this FCC deliberation period here. And so various parties on both sides of the issue, so our industry is going in, also the incumbents that are in the band are going in, and there are videos of me online. If you just Google Chuck and 6 gigahertz, you'll find that kind of go into the incumbents in great detail. And we're optimistic that we're going to see a report in order either late this year or in the first quarter of next year. What the NPRM contemplates is, this is how basically the band breaks down, and it's what we call the checkerboard. So basically Uni 5 and Uni 7, these will be so there's 4 new Uni bands is what's been proposed. So this is about 850 megahertz of spectrum, and it's high power in the sense that it's similar to Uni 3, but it is going to require database control. So AFC is automatic frequency coordination, and you can think of it as a lightweight spectrum database, so kind of like TV white space, but a lot simpler, right, and way simpler than what CBRS has. And then these 2 bands here are low power indoor, so you would not be able to use these for outdoor bands, but they would not require database control, and then client devices. So we have a lot of challenges with this approach. Yeah.
Why the seemingly random breakup between 5 and 6 and 7? And that just seems totally arbitrary. Like, why'd they pick these particular channels?
Yeah, so
allocate them for low power indoor.
So the answer is the incumbent. So if you looked at a breakdown of the band by incumbents, you would find that these actually correspond directly to breaks. So for example, Uni 6 is an exclusively mobile band. These 2 are fixed point to point from a microwave perspective. So it's harder to protect mobile incumbents. So I'm talking about TV trucks and police helicopters, that type of thing. So that's why this is indoor only.
Gotcha.
Yeah. Unfortunately, we don't have nearly as much time today as I would like to go into this, but we do have, again, there are videos of me going through the fundamentals in far more detail. So the dilemma this poses for us is, if we were to deliver this, right, the database, the products we could ship very quickly would only be able to turn up Uni 6 and Uni 8 because database bands take time to work out, right? We think the technology itself is pretty straightforward, but again, we have, from a regulatory perspective, we have to come to agreement with the incumbents, the commission has to agree, we have to test the databases, there have to be pilots, and so on, right, as you've seen in other bands. So if you think about CBRS, for example, that proceeding started 6 years ago, right? And the band is still not officially open yet. So we want to be able to ship, the whole band immediately. And another problem this sets up for us is, well, do we ship all the channels, even if we know, do we build the hardware so that it could be software upgradable later if we're not sure whether we would get the additional channels within the lifespan of that equipment, right? If it's another CBRS thing, right? I mean, why would you increase the cost to the customer to get spectrum that might not, because it's more expensive components, filters, and so on. So we counter-proposed, and we've been in, I'm in DC every 2 weeks now, and we're constantly presenting to them. It's quite an interesting record if you want to sort of get into the trenches on it. But what we came back and said, okay, we agree basically with standard power up here, but we think you can do low power indoor across the band, right? And it's safe and effective, and it's our responsibility to prove that that's the case. So we've done a lot of engineering studies, right? And we're doing product testing and so on. And then we introduced the concept of a very low power AP, because what do you do for the mobile tethering case, right? Or in-vehicle Wi-Fi application, right? It's not indoors necessarily, right? It's low power. So we needed a class that's indoor, outdoor, that really works with all the ways that people use their devices today. If I want to stream gigabit AR to an Oculus headset, for example, right? So I have a 5G connection to my phone, right? How am I going to get that gigabit link at low latency to my face, right? So we think a very low power class is the way to do that. And then we just said that the client device should match the power of whatever AP it's connected to. So this is the argument that we're carrying to the FCC right now. And then just a little bit about AFC. So the AFC...
Chuck, just a quick question on the previous slide. You said low power, is that 14 dBm low in the incumbent's mind?
Sorry, no.
Because 14 dBm actually is, for us, in our world, not that low.
True, but it's 16 dBm, right? 60 times lower than the indoor. So we have to, the notion is that we're trading off the ability to operate outside here, right? And so the concession that those devices make, and I agree that 25 milliwatts is not necessarily a lot in the broad sense of things, but you're going to only be able to maintain max MCS for a comparatively short distance. So that we talk to regulators about it in sort of the 1 to 3 meter use case.
But
Sam?
more importantly, though, I think the mandatory TPC where clients have to match AP transmit power, if you've got an AP that's at 36 dBm and the client has to match that, what's that going to do to our client? I mean, if this thing puts out 36 dBm because it's mandatory, what's that going to do to my battery life?
Well, the client is going to do whatever its capabilities are. So the client, you're not going to see a client that could do 36 dBm. The main reason,
it's not match transmit power, it's up.
Yeah, sorry. The reason for that is what they proposed in the NPRM was a hard cap at 18. So we didn't want to be in the opposite situation of the link imbalance.
Right.
Right. Okay, so just to maybe just wrap up here. So just real quickly on automatic frequency coordination. So this is something that we're going to spend a lot of time after the order kind of working out the details on. But the basic, the key incumbent in the band is point-to-point microwave, right? So this is a principal backhaul band. It has very nice propagation properties, and so telecom providers like AT&T, Verizon, railroads, financial services companies, utilities, right, are extensive users in this band. There's about 100,000 of these links across that range in the continental United States. And so obviously from an outdoor operation perspective, to protect those links, we need to make sure that the outdoor Wi-Fi, or what we call them RLAN devices, don't pose a risk to those incumbents. So the way that's going to work is for each of the receivers that's in the ULS database, which is a database the FCC maintains, so it's public. When you want to turn on an AFC controlled device, it's going to query that database. It's going to give its latitude, longitude, elevation, maybe its antenna pattern, right, depending on what the capabilities of the AFC. The AFC will run a calculation, and it will come back and say, these are the spectrum blocks in that range that are available or green for you at that location. And then the device will choose from that for its channel. Yep.
Is that querying just at setup, or is it periodic?
It will be periodic. It'll be required to revalidate that with some frequency, and that the duration of that interval is one of the things that's being debated in the proceeding.
And then what happens if, for whatever reason, it can't reach the database?
It would have to stop using 6 gigahertz. Yeah.
Is there an automatic entry made when that chooses?
I'm sorry, an automatic.
Is there an automatic entry made? It checks the database. It says you can use this frequency here, but now it decides to use that frequency. Is there an entry made for it?
Yeah, so you're saying, does the database then become aware of the choice
Correct.
that the device makes? This, again, is something that's being actively argued in the proceeding. Our position we don't think that's required because it doesn't really make a difference. In CBRS, that's how it works, but part of the point of CBRS is you have these protected access licenses. So part of the value of the PAL is that you get interference protection. With Wi-Fi devices, it's a completely different band, right? We don't have any peer-to-peer protection of any kind. So it's going to be a lot more complexity and cost if we have to do that. And there are privacy issues. So Apple, for example, has said in the record that they're worried about creating a traceable record of people's mobile devices, right? If you're tethering via AFC, right? So it creates some interesting dynamics. So anyway, the basic idea is if I'm outside one of these protection contours, I can use those channels. If any part of my service area touches, then the bandwidth of that receiver would be off limits to me, right?
Chuck, do you see this concept either currently or in the future being used for other purposes, like other coordination, DFS, anything else?
Yeah, so I think it may be used for non-Wi-Fi or non-unlicensed applications. So I think in general we're going to see a lot more dynamic spectrum access in other bands. Could be for industrial IoT type applications or what have you. But I think we would be really reluctant to take this back into 5 gigahertz. For example, we think DFS works pretty well for that. We don't need another mitigation in 5 gigahertz. Yeah.